The solubility product of barium sulfate at 25 degrees Celsius, 1 into 10 power minus 9. So K solubility value is there. What would be the concentration of sulfuric acid necessary to precipitate barium sulfate from the solution of 0.01 molar barium ions? See, you know barium sulfate formula BaSO4, sulfate of second group alkaline earth element. Barium sulfate is a strong salt, so it dissociates completely as barium ion Ba2 plus and SO4 2 minus. Suppose I add sulfuric acid now, H2SO4. When it ionizes, you know, sulfuric acid is one of very strong acid. It decomposes as 2 times H plus and SO4 2 minus. Now here sulfate ions are common, SO4 2 minus. SO4 2 minus either it should combine with the H plus or it should combine with barium ion. There are two possibilities for sulfate ion. If it combines with H plus ion, you must get back sulfuric acid. If it combines with barium ion, you should get back barium sulfate. But if you consider barium sulfate and sulfuric acid is one of very strong electrolyte, dissociates completely. Therefore, this reaction again not possible now. Therefore, sulfate ions forcibly reacts with barium ions. It gives barium sulfate back. Means the precipitation of barium sulfate takes place. You have initially barium sulfate solution here. It contains barium ion, sulfate ion. Add sulfuric acid to that solution. Now, some amount of barium sulfate gets precipitate here. This is the concept. You need to calculate what is the concentration of sulfuric acid necessary to precipitate 0.01 molar of barium ion. This is the question. See, consider barium sulfate. It gives barium ion and sulfate ion. So I can write K solubility now. K solubility equal to molar concentration of the metal ion, that is barium, into non-metal ion, that is sulfate ion, SO4 2 minus. Okay, so you need to calculate the concentration of sulfate ions now. So concentration of sulfate ions equal to K solubility divided by molar concentration of barium ion Ba2 plus. So K solubility value given in the question itself 1 into 10 power minus 9 divided by barium ion concentration is 0.01 molar, that is available here. So that is equal to 1 into 10 power minus 7 molar. That is the concentration of sulfate ions required. So this concentration is now 10 power minus 7. And as you know, if concentration of sulfuric acid is 1 molar initially, before dissociation, values of H plus and sulfate ion should be 0. And after dissociation, it should be 2 molar and this is 1 molar. Similarly, if concentration of sulfate ion is 10 power minus 7 molar, and this is the value after dissociation, it means that before dissociation, sulfuric acid value, it should be 10 power minus 7. The question is, what would be the concentration of sulfuric acid necessary to precipitate barium ion? Therefore, the right answer is 10 power minus 7 molar itself. That is the option fourth one.